Hello, my name is Stephanie Cleto and my partner is Andy Kim, and our presentation concerns the interpretation of an RGA matrix. In other words, how you might want to pair input and output variables based on the RGA. What is an RGA? An RGA is a relative gain array, which is an analytical tool used to determine the optimal input and output variable pairings for a multiple input, multiple output system. Below is an example of a relative gain array. Different columns represent the different manipulated input variables. Rows represent the different manipulated output variables. The values determined for an array can be used to explain the relationship between input and output variables. A negative value indicates an unstable relationship between the specific input and output. Values in an array that are equal to 0 can indicate that no relationship between the specific input and output exists. Finally, if a value of 1 is determined in the array, that particular input variable is the only influence on that output variable. In other words, a value of 1 indicates that the only influence on that output variable is that specific input. One example to look at using the RGA to explain the relationship between inputs and outputs can be seen here. Assume we have a mixing tank with a constant mass with two inputs, WA and WB, where WA and WB are the flow rates entering the tank to be manipulated. W is the flow rate exiting the tank, where XA can be taken to be the concentration in the tank. This system is modeled with these equations, where W is the sum of the entering flow rates WA and WB, and XA is calculated from the flow rate of A divided by the sum of the entering flow rates A and B. The relative gain array can be solved for the system giving the matrix shown here. For this specific case, the RGA tells us something for each range of desired concentrations of A. If a concentration of A is desired to be equal to 0.5, either entering flow rate for A or B can be manipulated. If a concentration of A is greater than 50%, then the entering flow rate for A, or WA, should be manipulated. If a desired concentration of A less than 50% is required, then the entering flow rate of B should be manipulated. For this second example, we are given a table of experimental data similar to the worked out example 2 from the wiki. A 2x2 RGA matrix can be found again describing the relationships between the inputs and outputs. It is important to note when pairing variables that values for each pair should be positive and close to 1. Since each combination in this example only has one positive value, then it can be concluded that R should be paired with XD and P should be paired with XB. For this third example, why don't you try it on your own? The solution for this example can be found on the attached PowerPoint presentation. Thank you and good luck.